Hello everyone, welcome back to our channel Begin Engineering. Today we'll learn about quadrature of plane area. Now see the process of finding the area bounded by one or more curves is called quadrature. Okay. Now let us see the theorem regarding this. So our theorem is let y equals to f of x is a function be finite and continuous in an interval a comma b, which can be represented graphically by a curve. Then integration a to b f of x dx is the area of the region enclosed by the curve y equals to f of x, comma, the ordinates x equals to a, x equals to b, and the x-axis. Okay, let us say it is, we have a curve something like this. This is our y equals to f of x curve, and here from a to b, from x equals to a to x equals to b, we are finding out the area of the curve. This height is our f of a, and this height is our f of b. So this is the theorem. The area under the integral is from x equals to a to x equals to b, f of x dx. And we can find the area if our curve is something like this. Then we can find the area as, let us say it is y equals to c to y equals to d. Then this area would be integration c to d f of y dy. Here we are taking this rectangle where this is your dx and this is your function, the height of the function f of x. That's why it is length into breadth, and from a to b, because we need the total area. And if you notice here y is changing, so this is your d of y, and this function is x equals to f of y. Here function is x equals to f of y. Here function is y equals to f of x. Here function is x equals to f of y. So here we can say it is y dx if it is in this format, and we can say this is x dy if it is in this format. So this is the thing you have to remember. Now let us see examples, because here you need a lot of concepts and you need observation. So let us see our first question, which is find the area bounded by the parabola y square equals to 4x and x square equals to 4ay. This is the question. So let us see how to solve. So in order to solve area bounded by the curves, the first thing you need is to draw the curve, because without drawing the curve you cannot solve questions. So here this curve is a parabola passing through origin. This is your y square equals to 4x curve, and there is a curve also. It is a parabola passing through origin, but it is the square is in x square, so it is symmetrical about y axis, and here we have y square. That means the graph is symmetrical about x axis. So this is our y square equals to 4x curve, this thing, and this curve is our x square equals to 4ay curve. Okay, and we need to find this area. So first of all, let us find the intersecting points. So to find the intersecting points, we have to solve these two equations. So if you solve these two equations, that is y square equals to 4x and x square equals to 4ay, you have to solve. If you solve, you will get x equals to 0, y equals to 0. That means put any one of the value, let us say y equals to x square by 4a in this equation, and then you get one equation, solve. From this you will get x value, and put in other, you will get y value. But here we have squares, so you'll definitely get two values. So x equals to 0 and y equals to 0, and x equals to 4a and y equals to 4a is the other point. So this is your, let us say, origin. This is your 0 0, because the curves are intersecting here, and this point is 4a comma 4a, because the curves are intersecting here. So let us draw a perpendicular here. This is 4a, this is 4a. So this point is 4a comma 0. So what is the area? We need this area. How to find? Area bounded by this curve, that means this whole area, and area bounded by, if we subtract area bounded by this curve, that means this much area. So we'll get this area, this area. So we can say that area is integration for this curve, it is 0 to 4a, because we need x values. 0 to 4a y dx. Here y is, we have taken this curve, minus integration again for this, it is 0 to 4a y dx. Here we have to use x square equals to 4a y curve. So let us put this is 0 to 4a and y is square root of 4x dx, minus, from here y is x square by 4a, so 1 by 4a is constant, keep it outside, 0 to 4a x square dx. So from this we can say square root of 4 is 2 and square root of a, that is 2 square root of a integration 0 to 4a x to the power half dx, minus 1 by 4a integration 0 to 4a, this is x square dx. So this integration would be x to the power half plus 1 by half plus 1, and if you put 0 to 4a, you have to put 0 to 4a, and this would be x cube x to the power 2 plus 1 by 2 plus 1, and you have to put the limits 0 to 4a. And if you solve, you will get 16 a square by 3 square unit. I am not solving every steps because I want to focus in solving more types of questions so that your concepts will be crystal clear. Otherwise, this video will be too long. Now, let us see our next question, which is find the area of the region bounded by pi cube equals to x, the y-axis, and y equals to 3 and y equals to 6. So let us see the solution step by step. Here y equals to curve, y equals to x equals to y cube. These curves looks something like this. Let me draw it clearly, otherwise you will be confused. This curve is something like look like this. Okay, this is the graph of y equals to x equals to y cube. Now we are given that we have to find the area bounded by this curve and y equals to 3 line. Let us say this is our y equals to 3 line, this is y equals to 3 and y equals to 6 line. Let us say this is our y equals to 6 line and y axis. So we have to find this area, y axis, y equals to 6 line, y equals to 3 line, and the graph. That means we have to find this area. So here we will apply the second methods, that is integration. Here limit would be We know this is x dy because here y is changing. Here y is changing. This is your dy. So limit would be y. So it is from 3 to 6 x dy. Now what is x? X is y cube. So integration 3 to 6 y cube dy. This integration y to the power 4 by 4, 3 to 6. This would be 6 to the power 4 minus 3 to the power 4 by 4. So if you calculate, you will get 303.75 square unit. This is the area. Now let us see our next question, which is prove that the area bounded by the semi-cubical parabola y square equals to a x cube and a double ordinate and the double ordinate is 2 by 5 of the area of the rectangle formed by this ordinate and the abscissa. So let me draw the diagram first. We need to draw the semi-cubical parabola, that is y square equals to ax cube, and semi-cubical parabola looks something like this. This is your semi-cubical parabola. Okay. Now let us say now this is okay. Now let us say that at x equals to b, be the double ordinate of the parabola AB. This is the A, this is AB is the double ordinate of the semi-cubical parabola. Let us say this is the point C and this is b comma 0. Okay. So let x equals to b be a double ordinate AB drawn at the point C b comma 0. So we need the area bounded by semi-cubical parabola, and the double ordinate is 2 by 5 of the area of the rectangle formed by this ordinate and the abscissa. So let us say this is our O So we need this area. So our area OCA, this would be integration from 0 to b y dx. So this would be 0 to b. And what is y? It is a to the power half x to the power 3 by 2. This is a to the power half x to the power 3 by 2 dx. And if you solve this, you will get a to the power half, and this x to the power 3 by 2. If you integrate, it will be x to the power 3 by 2 plus 1 by 3 by 2 plus 1. And then you have to put the limit 0 to b. If you put this, you will get, okay, let us solve. So this would be x to the power 3 by 2 plus 1 by 3 by 2 plus 1 from 0 to b. So you will get 5 by 2, that is 2 by 5. So 2 by 5 of a to the power half. And if you put b here, it would be b to the power 5 by 2, and 0 minus 0, that is 0. So this would be b to the power 5 by 2. So what would be the area? The total area would be this. Total area is this, because we need the area bounded by the semi-parabola, semi-cubical parabola, and the double ordinate. That means this total, and the graph is symmetrical. So we can say total area would be twice of what we got into 2 by 5 into a to the power half into b to the power 5 by 2. So it will be 4 by 5 into a to the power half into b to the power 5 by 2 by 5. Okay. Now let us put x equals to b in this equation. We have y square equals to ax cube curve. This is the equation of semi-cubical parabola. Now let put x equals to b in this equation. So y would be a to the power half into b to the power 3 by 2. Now the rectangle, the area of the rectangle formed by the ordinate AB and the abscissa. That means this is the area. This is the area of the rectangle. And this area would be so area of the rectangle formed by the ordinate AB and the abscissa is B into 2a to the power half into b to the power 3 by 2. See, this y is b to the power half into b to the power 3 by 2. So it is symmetrical. So this should be your total length. And this is twice of a to the power half into b to the power 3 by 2. And we know the breadth, that is b. So b into twice a to the power half into b to the power 3 by 2. So we can say this area is, we got the area as we need to prove that this area is 2 by 5 times the area of the rectangle formed by the ordinate and the abscissa. So the area we got is 2 by 5 into a to the power half into b to the power 5 by 2. So we can say that, sorry, we got this area 4 by 5. So we can write it as 2 by 5 into twice a to the power half into b to the power 5 by 2. Now this area, that is 2 by 5 times, and this is your twice a to the power half into b to the power 1 b to the power 3 by 2, that means b to the power 5 by 2. So 2 by 5 times the area bounded by this semi-cubical parabola and the double ordinate. 2 by 5 times the area of the rectangle. Okay, this area we got as this, and this area is 2 by 5 times the area of the rectangle formed by the ordinate AB and the abscissa. Okay, so this is the proof we need. Okay, now let us see our next question, which is find the area included between the rectangular hyperbola xy equals to c square. X-axis and the ordinates x equals to c and x equals to 2c, where c is greater than 0. Now we know that rectangular hyperbola is looks something like this. This is your rectangular hyperbola. Okay, this is the graph of xy equals to c square. So our area would be rectangular hyperbola this x-axis, the ordinates x equals to c, that is, let us say this is your x equals to c line. Let us say this is your x equals to 2c line, and you need this area only. So this would be integration from c to 2c y dx, and y is c square by x. So this would be c to 2c c square by x dx. This would be c square, and 1 by x integration is log of x, and always keep mod because log of negative is undefined. C to 2c. Now we put the limit, this would be log of 2c minus log of c, and c is greater than 0 is given. So that's why we have omitted the mod now, because we have confirmed that c is greater than 0. It is given. So log a minus log b is log of a by b. So this would be log of 2c by c. That means c square log of 2 is the answer. Okay. Now let us see our next question, which is prove that the area bounded by the hyperbola x square minus y square equals to c square, x axis and a line drawn from the origin to any point, let's say x naught y naught, on the hyperbola is c square by 2 log of x naught plus y naught by c. So let us see. So it is given that we have a rectangular hyperbola. This is the equation of rectangular hyperbola. So graph is this. This is the rectangular hyperbola. This is y, this is x. Prove that the area bounded by the hyperbola this x-axis is your x-axis, x-axis, and a line drawn from the origin to any point x naught y naught, both are positive. So let's say this is the line. It says x naught y naught. This graph will look something like this. Okay. Now let us draw a perpendicular here. Okay. So what would be the area? Area bounded by the hyperbola this x-axis and a line drawn from the origin to any point x naught y naught on the parabola is this. So we need this area, this total area. So we can say that our required area is Let us name it. This is OQ. So this is area enclosed by the straight line OQ, x-axis, let's say this is our P, this coordinate is x naught comma 0, and the ordinate POP minus area enclosed by the right branch of the hyperbola and x-axis, and the ordinate QP. So this, okay, you need this area, but if you talk about this triangle, this straight line, this is the total area, and we have to subtract this much area. That's why this is minus area enclosed by the right branch of the hyperbola and x-axis and the ordinate QP. That means you have to subtract this area to get this much area. We need this much area. So limit is from, this is 0 to x naught. So integration 0 to x naught y dx. Okay. Now what will be the equation of this y? This is your x naught y naught, and we know this is the line passing to origin. That means the equation of the line would be y equals to mx. And what is m? From this right angle triangle we can say m is tan theta, that is slope, that is y naught by x naught into x. This is the equation of this straight line. And this is for it, for the straight line, y equals to y naught by x naught into x minus integration from this is your c point, c comma 0. So from c to x naught, from c to x naught, and area bounded by this hyperbola. Here x square minus y square equals to c square. That means y square would be x square minus c square, and y would be square root of x square minus c square. So this would be square root of x square minus c square into dx. And this area is bounded by the curve x square minus y square equals to c square. So let us solve. So let us first put the values. This is 0 to x naught. Y is y naught by x naught into x dx minus integration c to x naught square root of x square minus c square. This is c square dx. Y naught by 6 x naught into this is x square by 2 from 0 to x naught. If you put the value, you will get x naught square by 2 minus, let us apply this formula, square root of x square minus a square. This is the formula is x by 2 function minus a square by 2. It is c square by 2 log of x plus function. Okay, from c to x naught. So let us put the values. This would be 1 x naught will cancel out. This will be x naught y naught by 2 minus. Now we have to put the values. The upper limit is x naught by 2 square root of x naught square minus c square minus c square by 2 into log of mod of x naught plus square root of x naught square minus c square. This is upper limit minus lower limit. If you put c, this will be 0. This will be 0. So this would be minus minus plus c square by 2 log of c. Okay. Now let us solve x naught y naught by 2 minus, this would be, see, we know that the curve is x square minus y square equals to c square. So if you put x naught y naught there, so curve is x square minus y square equals to c square. So if you put x naught y naught, it would be x naught square minus y naught square equals to c square. So x naught square minus c square would be square root of y naught square. Y naught square root is y. So this would be x naught y naught by 2. This minus minus would be plus c square by 2 into log of, it's again y, x naught plus y naught. Okay, and this is minus plus minus minus, this is c square by 2 log of c. Okay, now this will cancel out. Now ultimately we got c square by 2 if we take common. This is log a minus log b, that is log of a by b. So log of x naught plus y naught by c. This is the thing we have to prove. Okay, now we will solve 3 more questions to understand this topic more clearly. Let us say our next question is, show that the entire area of the asteroid, this is also known as hypocycloid, x to the power 2 by 3 plus y to the power 2 by 3 is a to the power 2 by 3 is 3 by 8 pi square. So this graph is look like this. Okay, this graph is hypocycloid or straight. This point is a comma 0. We need the entire area and it's a symmetrical curve. So at last we will multiply by 4. Let us first find this area and we will multiply by 4. So we will get the total area. And this asteroid is symmetric about x-axis and y-axis. So let us first find this area. This area would be from integration 0 to a. And if you want to know how we get this a comma 0, so if we need the x intersection, put y equals to 0. So if you put y equals to 0 here, you will get x equals to a. This would be y dx. Now 0 to a, what is y? Y would be a to the power 2 third minus x to the power 2 third by 3 by 2. So this would be a to the power 2 third minus x to the power 2 third to the power 3 by 2 dx. Now let us put, let x equals to a sine cube theta. So differentiate both the sides. We will get dx equals to, this is 3a sine square theta into differentiation of sine theta is cos theta d theta. You have to change the limit because we are using substitution method. If x equals to 0, theta will be 0. If x equals to a, if you put a here, it will cancel out. If x equals to a, theta would be sine inverse 1, that is pi by 2. So our limit changes from integration 0 to pi by 2. This would be a to the power 2 third minus x is a sine cube theta. So cube and 1 third will cancel out. We will get a to the power 2 third into sine square theta to the power 3 by 2. And dx is this thing, 3a sine square theta cos theta d theta. Okay. Now this will be, if you take a to the power 2 third common, so a to the power 2 third, you have to the power 3 by 2. So 2 third multiplied by 3 by 2. So it will be a, and a multiplied by a would be a square. So outside we got 3a square. 0 to pi by 2. This is 1 minus sin square theta, that is cos square theta, and this cos square and this 1 half will cancel out, and you will get cos cube theta. Cos cube theta and cos theta, this would be cos to the power 4 theta multiplied by sin square theta d theta. Now if we take cos square theta from here, sin square theta from here, and if we multiply by and divide by 4, so 4 will go inside, and it will be 2 sin theta cos theta whole square. That means sin 2 theta whole square. So it would be sin square 2 theta, and we remain with 1 cos square theta outside d theta. So this would be 3a square by, let us say, 3a square by, let us say, 16 multiplied and divide by 4. This would be 0 to pi by 2. We multiply by 4 here. So if it is under square, it will be 2 sin 2 theta cos theta whole square. So 2 square is 4. 4 and 16 cancel out to give 4 d theta. Okay. Now this is 3a square by 16 into 0 to pi by 2. We can say that this is 2 sin a cos b formula. We have to apply 2 sin a cos b formula. This is sin of a plus b plus sin of a minus b. So this would be sin of 3 theta plus sin of theta whole square d theta. 3a square by 16 multiplied by 0 to pi by 2. This is sin a plus b whole square. That is sin square 3 theta plus sin square theta plus 2 sin 3 theta sin theta into d theta. So this would be 3a square by 16 integration 0 to pi by 2. This would be sin square 3 theta. So sin square theta, we know that 1 minus cos 2 theta is 2 sin square theta. So sin square 3 theta would be 1 minus cos 6 theta by 2. This would be 1 minus cos 2 theta by 2. Because see, we have 1 minus cos 2 theta, that is 2 sin square theta. So if we have theta here, we will get 2 theta here. So if you have 3 theta here, you will get twice of 3 theta, that is 6 theta. Plus this is 2 sin a sin b formula, that is cos of a minus b minus cos of a plus b. So you will get cos of 2 theta minus cos of 4 theta d theta. So this would be 3a square by 16 0 to pi by 2, and if you take 2 common here, so it will be 3a square by 32. It will be and If you take the LCM, this will be 1 plus 1, that is 2, minus cos 6 theta plus cos 2 theta, because 2 cos 2 theta minus cos 2 theta, that is cos 2 theta, minus 2 cos 4 theta. Now we will be able to solve the integration. 3 square by 32, 2 d theta, integration is theta, so 2 theta, cos theta, integration is sin theta, but here we have cos of a theta, d theta, so integration will be sin of a theta by a6. So this would be sin of 6 theta by 6. This would be sin of 2 theta by 2. This would be 2 sin of 4 theta by 4, from 0 to pi by 2. And if you put the limits, pi by 2, 0. If you put 0, all of the things will be 0. And if you put pi by 2, then you will get the whole value as pi. So this would be 3 square by 32 into pi. So it will be the required area. Required area will be 4 times 3 pi a square by 32. So this would be 3 pi a square by 8. This is the area we need. Okay. Now let us see our next question. Remember the procedures, because here procedure is important. Otherwise, we will not be able to solve this type of question. Now, let us see our next question, which is draw the curve volume of Descartes. Volume of Descartes. X cube plus y cube equals to 3axy. Find the area. Find the area included within its loop. See, our volume of Descartes is a complex graph, means its method to draw this graph is very complex. So I will explain this in a separate video. Here I am drawing the required volume of Descartes graph. The graph looks like something like this. This is the graph of volume of Descartes. Let us say this is O, this is P, and let us say this is Q. Okay. So this graph has a loop OPQO. Now, if we want to solve this integration by coordinate system, Cartesian coordinate system, it will be very complicated. So let us solve by polar coordinate. So let r comma theta be the polar coordinate of a variable point moving along the loop. Okay. Now theta equals to 0 at origin at O, and when the points returns to O after tracing the whole loop, theta will be pi by 2. Okay. Now area of the loop will be half of integration theta 0 to pi by 2 r square d theta, where remember x is r cos theta and y is r sin theta. Okay. Now let us put this value in volume of Descartes graph equation. X cube plus y cube equals to 3axy. So we have x cube plus y cube equals to 3axy. So let us put these values here. So x is r cos theta. That means we have r cube cos cube theta plus r cube sin cube theta, and this is 3a r cos theta into r sin theta, that is r square cos theta into sin theta. So from this we can say that r is, if you take r cube common, r square will cancel out with r cube, and here r is 3a sin theta cos theta upon sin cube theta plus cos cube theta. So our required area is integration theta is 0 to pi by 2. This r square would be square of this thing. So we got 3a sin theta cos theta whole square by sin cube theta plus cos cube theta whole square d theta. Okay. Now this would be 9a square, 9a square, and this is sin square theta cos square theta 0 to pi by 2. This is sin square theta cos square theta sin square theta cos square theta upon sin cube theta plus cos cube theta whole square into d theta. Okay. Now we can say we have a half here, so it would be 9a square by 2. Now we can write this as 9 a square by 2 integration 0 to pi by 2 tan square theta, and if we divide by, let us say, cos cube theta. If we divide by cos cube theta, then this would be cos. Let us divide this by cos to the power. How to reduce this? Okay, if we take cos cube theta common from this, so it will be cos to the power 6 theta. Okay, so 1 cos square theta will cancel out, so we have in the denominator cos to the power 4 theta. So 1 by cos square theta would be sec square theta, and sin square theta by cos square theta would be tan square theta. So ultimately it is tan square theta sec square theta upon 1 plus tan cube theta whole square into d theta. Now let us say we have, let 1 plus tan cube theta is d. So this would be 3 tan square theta. Differentiation of tan theta is sec square theta. D theta would be dt. So in place of tan square theta, sec square theta, d theta, we will put dt by 3. This 3 and 9 will cancel out. We will get 3 by 2 a square. And if you put theta equals to 0 here, you will get t equals to 1. And if you put theta equals to pi by 2, tan pi by 2 is infinity. So infinity, and it will be 1 by t square dt. Now see, here it's a improper integral where upper limit is infinite. So we have uploaded a video of how to solve improper integrals. So if you have any doubts, please watch that video. We can write this as 3 by 2 a square, limit x tends to infinity, integration 1 to capital X, 1 by t square dt. And it would be this would be t to the power minus 2. Then we will get t to the power minus 2 plus 1, that is 1 by t, by minus 2 plus 1, that is minus 1 by t, from 1 to x, limit x tends to infinity, 3 by 2 a square. So this would be 3 by 2 a square. This would be limit x tends to infinity. If we take minus common, that will be 1 by x minus 1 by 1. So x is tends to infinity, 1 by infinity is 0, minus minus plus. So ultimately we get 3 by 2 a square. So this is the answer. Okay, remember this is very important. Now let us see our last question, which is find the area included between the catenary. See, a catenary is a chain when it is hung from two of its ends. That is catenary. Y equals to a by 2 e to the power x by a plus e to the power minus x by a. or it's a hyperbolic function. This is actually y equals to a cos of h cos hyperbolic of x by a. This thing. The x-axis and the lines x equals to 0, x equals to b. Okay. So let us draw the catenary. It's a hanging chain. Let's say this is 0, a point. This is your AB catenary, and we need x-axis x equals to 0. X equals to 0 means y-axis, and x equals to b line. So this is your x equals to b line, and this catenary. Okay. So this catenary graph is symmetric about y-axis. Its vertex is at 0, a. And what is area? This much area we need. So our area would be integration from 0 to b, 0, 0, 0 to b y dx. Okay. Now let's put y here. Y is a by 2 into e to the power x by a plus e to the power minus x by a into dx. Now we know e to the power x integration is e to the power x, but here it is e to the power a into x. So divided by a, that means divided by 1 by a would be there. So it would be a by 2 divided by 1 by a. So a into e to the power x by a, and this would be minus a into, because it would be minus 1 by a minus x by a from 0 to b. So if you put the limit here, it will be a by 2 is upper limit. If you take a common, so it will be a square by 2. It will be e to the power b by a minus e to the power minus b by a minus e to the power 0 is 1, e to the power 0 is 1. So it will be 1 minus 1. So this is a square by 2 into e to the power b by a minus to the power minus b by a. Okay. So this is your required area. Okay. And you can say that this is sine hyperbolic formula. This would be a square into sine hyperbolic b by a. Okay. So this is the area. So this area chapter is not difficult, but what you have to do, keep the patience, and you have to practice on your own some questions, because here you will see, or here you will encounter with different types of graphs. So you need to you should have that experience of different types of graphs, so that if it is come in your exam, you will be able to solve it. So that's all for today. If you like the video, please like, share and subscribe. Share with your friends and comment down in the next video what chapter you need me to upload. Thank you. Have a good day and take care of yourself.